and welcome to episode 75 of the Gaslec podcast. In this week's episode, we're going to be looking at the history of the TRV. We have some listeners' questions that we answer, and we look at the world of heat loss and some very simple explanations for that. But before we get into the podcast, here's my friend Sean to tell you a bit more about it. Are you a new person coming into plumbing and heating? Are you a homeowner that likes a bit of DIY? Or are you a business owner and wanting a bit more knowledge before you make some decisions on your plumbing and heating? Stay tuned to the podcast and hopefully we'll be able to help you out with some of your questions. And welcome back to the podcast, and thank you very much indeed for listening, guys. Thank you. So some listeners' questions. So why does my boiler lose pressure? So we're talking about a sealed heating system before. I think we've gone through this before in other podcast episodes, but I'll go through it again. So we have a sealed system. So we have, in theory, the water cannot leave our heating system. So it goes through a typical wet radiator system, goes back to the boiler, and then goes round in a lovely little circle with the pump. So we have a couple of points where we can lose the pressure from or lose the water. So the first things first is, if I get a call out for you boiler losing pressure, I'll be looking at the expansion vessel. Where we've got it, maybe inside the boiler, it may be external to the boiler, all depends on your system. And I'll be checking that and checking the pressure. I'll also be asking how often you losing the pressure. So is this a once a year thing? Is this a once a week thing? So get a bit of an understanding of how the frequency that we're having to top this up as well. So typically what happens is water will be leaving the heating system. And the most common place for that is the expansion vessels, which is a bladder of air inside some sort of, sometimes a rectangle, sometimes they're like ball type things. And it's full of air, and basically the air is leaking, and it allows more water to go in. And it'll get to a point where the pressure builds up so quickly with the rate of expansion not being there, it'll open up the pressure release valve, which is a safety device built into your boiler or into your heating system. And then typically that water will escape that way. And with old PRVs, pressure release valves, what they'll do is they don't seat properly, and then they carry on dripping. And it's normally a little copper pipe that'll be going outside the back of the boiler somewhere, typically where the flue is. You normally see it dripping out the back. So that's the first place I'll be looking. So second place is inside the boiler, we'll have an air admittance valve. So sometimes these can go wrong and start weeping and letting some water out in that way. But for you, for the homeowner, the most obvious and the first thing I will be going around and checking is, do you have any new stains on your ceiling from any watermarks within the ground floor, looking up underneath the pipework and the radiators? If you don't have any of that, check all your radiators to see if there's any crusty marks around the valves or any rust around the bottom of the radiators. Now, what I will say is, if you do find any crust around valves, on the radiators, any like blistering of the paint where you think there might be rust underneath, don't start scratching it, because it's like a scab on your knee when after you're falling over. You pick it, it'll start bleeding again. But ultimately, if you pick it, it will start leaking water, probably even more so than it did before. So if you find any crusty bits, don't try and clean it up. Then get somebody in, or get it, or do it yourself and get the item replaced. So that's really where we start losing pressure. That's where we start looking at things there. So our TRVs were fitting. So TRVs, thermostatic radiator valves. So these limit the heat. It's like a temperature limiting device for the radiator or immediately around the radiator. So it doesn't really do the whole room temperature. It just does in that little area around by the side of the rad. So from a high temperature heating point of view, I'm going to go through in the history section some other little bits and pieces which will tie in nicely with this question actually today on this week's episode. So for high temperature heating, which is your normal heating around that sort of 60-70 degree mark, TRVs worth it, and they are a temperature limiting item. So if an area or a radiator around an area gets to a temperature, whichever you set it to, it will then just cut off and stop the water flow through there. So if you've got like a bedroom that you don't really use, like a spare bedroom, you might want to, if you've got a radiator valve that's set 1 to 5, you might want to set that around maybe the 2 mark in the depths of winter, and that will allow a trickle of water through the radiator just to take that big chill off the room and keep the damp away. And in living rooms, we may be setting these to 4s, maybe 4.5s, and into bedrooms around the sort of 3.5 marks on those. And it ways of limiting the temperature. But later on in this episode, I'm going to go through some other bits and pieces to do, which will tie in with that question as well. What's the difference between a programmer and a thermostat? Now, when you're in the industry, you know what it is, and it seems like a bit of a silly question, but it's not a silly question. So if you don't know what you don't know. So a thermostat, like a room thermostat for your heating, you can then set this to say 20 degrees. And at that point of the thermostat, there'll be a little sensor in there, and around the 20 degrees, it'll click in or click out, whichever way it's working. Now, a programmer will actually turn off the boiler and all your heating system or your hot water system, because it can do both, and then it will come on at certain times. So it's like a series of switching. So the programmer, if you're asking for heating for 2 hours in the morning, and regardless of what the thermostat's doing, it'll only respond and turn on if the programmer's actually on as well. So think about it as a series of switch. Is the programmer on? Yes. Is the thermostat calling for heat? Yes. Then your boiler and heating will come on. So a programmer just turns it on. Yeah, and then so it's a separate item. I've been to quite a few tenanted properties where they only have a thermostat, where they'll just turn it on and off from the stat, which is a bit of a waste of energy. And I've been to some, they're the other way around. They have like the mechanical clock on the front of the boiler, and they just tell the tenants just to turn it on for a couple of hours and to try and limit and work the temperature of the property around that way, because the landlord's not paying for the bills. If they were paying for the bills, they'll have a programming thermostat in there, I'll tell you that for free, because it's the most cost-effective way of running your heating system. What is a carbon monoxide alarm? So when we burn any fuels, so that will be solid fuel, wood, coal, and we're burning gas, we're burning an oil of some description. The downside with that is carbon monoxide. So we have to really monitor. So when we're doing our installations, when we're doing our boiler services, we monitor for our FGAs up in the boiler flue, how much carbon monoxide during combustion is being released. So it's really, really important to keep on top of these numbers. And correct servicing of certainly modern boilers will actually see these in very, very low numbers. But what we need to make sure is if there was a disaster with high CO numbers, CO being the chemical code for carbon monoxide, if we get high CO and there was a leak on the flue or the fumes were coming into the property, we need to make sure that there'll be an alarm, because these are odorless gases that are coming in that will actually poison us. And they'll actually attach, carbon monoxide attaches to the red blood cells within your blood, and it stops your body from absorbing oxygen. So you're almost like asphyxiation. And that's why you can start getting brain damage, and all the different parts of your body that needs oxygen starts getting starved of it. And that's why it's so, so dangerous. So what I would say is, wherever you've got a gas burning appliance, have a carbon monoxide alarm. And certainly, we don't do it here at Gaslec, certainly if you've got a solid fuel burning appliance like a log burner, I'd definitely have one there. Funny enough, I did a job last week and the lady had 2 CO alarms next to her log burner. So just in case if one did fail, the other one's there for a backup. And for the sake of 15, 20 quid, I'd certainly have 2 as well, just to make sure. the history section of the podcast. So, we're going to go into and start talking about the TRV. So it all links in with that other question, really. So the thermostatic radiator valve. So the first true thermostatic radiator valve was invented in 1941 by Danfoss. It's a Danish company founded by Mads Clausen during World War II. And materials were scarce, so the early models are mostly used in large buildings rather than homes. In the first of the TRVs, they used bellows systems filled with gas or liquid, which expanded as the room warmed up, and gently pushing down the pin to reduce the flow of hot water through the radiator. By the 1950s and 60s, TRVs have become more compact and reliable, allowing them to be fitted in domestic heating systems. This gave homeowners individual control over each radiator for the first time, a big step forwards towards modern energy efficiency. And in the 70s, as oil prices soared and energy conservation become a focus, TRVs become a standard part of efficient heating design. Modern designs still use the same basic principles of a sensor head that reacts to temperature changes. But today's valves are far more precise and durable. Fast forward today and you have some smart TRVs that are connected to apps, learn your habits, adjusting temperatures automatically, and even working alongside voice assistants or smart thermostats like Hive, Tado and Honeywell Evo Home. So from a simple mechanical valve invented in wartime in Denmark, the TRV has evolved into the key player into a home comfort and energy efficiencies, and without even notice most of it all of the time. And as we go into, I still go into homes in 2025, and we still don't even have them on high temperature heating heating designs. So it's something that's been around for a long time, and some people don't even actually use them. But actually, on low temperature heating designs, they're actually considered a waste of energy. So TRVs are a way of limiting temperature into that area. So then what it'll do is it will shut down and force all the energy down to another area, and then that will get overheated, that will close down, that will get overheated and get closed down. But the boiler's still running, still producing energy, still producing temperature, the pumps are still running, and potentially all the radiators start closing down. And then we're putting too much demand in and energy into the boiler, and all it's doing is just circulating it within a very small circuit. So in low heating design, we talk about balancing heating systems and using lock shields just to get the flow rate correct through the whole heating system. And the idea is that basically the boiler doesn't really turn off in the winter. It just runs at a low temperature all the time just to maintain that steady temperature throughout the building, which is fantastic for underfloor heating. So the TRV's been around for a while, but ultimately we're going to start be moving away from the TRVs. But it's a very easy way, very quick way of saving a bit of energy if you don't have any on high temperature heating circuits. And certainly if you don't know how to set the system up as well, it's a great way of doing that and stopping rooms getting overheated. Amount of times we go into places and the heating's roaring, the thermostats turn around to 5, and then they've got the window open because they're too hot. So a little bit of education there when we get the opportunity and we get that done. So I want to talk about heat loss really in this week's episode. So heat loss. So I was going through some heat loss with a commercial client the other day. They had a really old boiler. It was a floor standing Mexico boiler with a permanent pilot light in a commercial property. We had 35 mil flow and returns to it. So it was quite a big, the pump had a flange on it. So it's nice big pump onto there. And I was talking about heat loss. So I said, if we had a 20-degree pipe and a 20-degree air temperature, what's the heat that would transfer backwards and forwards? And in theory, take away some of the other bits and pieces to do with it. Ultimately, nothing would change. 20-degree one side, 20-degree the other. Nothing is more or less the other way. So no heat would actually transfer because they'll both be the same at that point. So if you had a 20-degree room temperature and a 30-degree or a 40-degree flow of temperature, you would start losing the heat from one side going over to the other. And so when we've got pipe work that's not insulated and lagged as it's passing through, even within the envelope of the building, let alone going into lofts and outbuildings, um, we need to start thinking about the surface temperature of the pipe as well as the air temperature. And the bigger, greater difference there is between the two, the more heat is lost and radiated out of the higher side. So in theory, if you had 0-degree water flowing through a pipe and a room that's really, really hot on the hottest day of the year, in theory, you could cool down the room by putting freezing cold radiators, which will then draw the heat in. Doesn't actually work that way in principle, but that's a bit of the idea. But you can imagine that the other way around. So then we start looking at heat loss and we start looking at windows. Now, windows are a terrible way of insulating from the outside to the inside. They do their best, and with all the modern gases they put in windows, the triple glazing, but ultimately the very nature, if you've got a 9-inch brick wall with insulation in it, and then you've got a glass window, even if it was 50 mil thick, the U value, the insulation value will still be a lot less. So then that starts making me talk about and think about like my own home made in the 1930s. I've got a suspended floor. So I have air bricks at the front and the back. I have a void which varies in depth. It really does under my house because I'm on a bit of a hill. And the air blows through underneath. And we need that because I've got a timber suspended floor. And in theory, the floor underneath my house is rubble really, but ultimately it's dirt. If we keep digging down under my house, there's no insulation, there's no membranes or barriers or damp proofing at all. It's just dirt. So we need those air bricks underneath to be able to maintain that airflow and make sure that we don't get the build-ups of damp and all the rot, the wet rot, the dry rot, and the infestations that we can, funguses that can grow because of it. So we need to keep that vented underneath the house, and chimneys as well. If you've got an open chimney that goes up, you can't just block it off. You've got to have an amount of airflow through, otherwise you will start be suffering with damp. So, but that's also another place for heat loss. So literally heat will fly up the chimney and disappear out. And if you've got a drafty under the floor on a windy day, you will get small cracks and around by the skirting boards and the doorways where you will be getting heat loss through there as well. So it's a great idea at the stage that you're doing some decoration is to lay down some ply over your floorboards and try and seal this in from the vented underneath up into the room. And if you can, go between the floors and then insulate between the two to stop the heat being taken out rather than the cold sort of coming up and through. So that's a really, really good way of saving some money there. But what you're trying to do is reduce your heat loss. We can put loads and loads of energy in, of course we can, which costs us more money, or we can try and stop what we have from escaping. And home insulation is really, really all about that. So yeah, thick curtains up at your windows, certainly in the winter, really does help. If you've got some patio doors, so nice thick curtains, and draw those too, that will help. If you've got a large space, I saw this on a boat actually a few years ago. There was a large sort of communal space on this converted barge. It was huge. And what they'd done is they had some thick curtains and they created these like little rooms just through curtains for the winter. And it was phenomenal. The heat, you'd stood one side of the curtain, you opened it, and the heat difference going into that area behind the other side of the curtain was phenomenal. I would have never ultimately knew it was possible, be honest. So yes, some thick heavy curtains can help with your heat loss as well. And obviously your front door letterboxes go out to the outside, little draft excluders underneath your doors, making sure your doors fit nice and properly too. So yeah, that's hopefully I can explain a little bit about heat loss there within your own home and little things that you can do to save it. So this week we've had 53 jobs here at Gaslec. We've got completed for across the whole team. So heating season, winter season, silly season, whatever you want to call it, is well underway. Fantastic. It's great. We did actually have a really busy summer this year here at Gaslec. Probably the busiest summer we've had on record coming through. So, you know, we're doing something right here, which is great. And we're getting some fantastic clients, domestic and commercial, on board. Already for next week, we have 37 jobs already booked in for next week. We have some, I like to try and keep myself clear for some problem solving and the commercial works as it comes through, but we already have 37 jobs pre-booked in. So we can get to around the 65 to 70 jobs a week. That's sort of our max really for the team. If they are sort of simple jobs to get in and out to get done. So we are looking at, and we are growing the team here at Gaslec. So I'd like to be able to get up to 100 jobs a week. That's why I'd really like us to be here, for everything to all the mechanics of it all to start working. So that concludes this week's episode. So I've been rattling for 20 odd minutes. So thank you very much indeed for listening. I've been working really hard on another little studio layout for the podcast. It's going to go down the other end. So once that's done, we'll transfer everything over. I've built this lovely new desk yesterday. I'm recording this on Sunday the 5th. So I bought, that was the majority of yesterday, was making this new desk idea. We're going to get it all painted up and create a new backdrop and stuff like that. So yeah, I've got my new Temu duck with the glitter on it, and I've got my new little lemon van up there as well. I'm a bit of a softie when it comes to old toot like that. Okay, guys. Well, thank you very much indeed for listening. If I can ever ask, if you can just share this podcast with one person that if you think they are a DIYer, they want to be coming into the plumbing and heating industry, they work maybe in a school caretaker role, some sort of maintenance within their own industry of what they do. If you can share this podcast with just one person, that will be a massive help to us and to the algorithms as well. You take care, and thank you very much. Have a great week. Goodbye.